If you're trying to communicate that it's an angle very quickly, as opposed to someone going, wait a second, what is he? Oh, it's an angle. You would put in radians. The reason why it's unitless is, as part of this relationship here, the arc length is equal to the radius times the angle. So if this is S, this is R, and this is the angle theta, if theta is in radians, this relationship holds true. Which means that the angle in radians is equal to S divided by R, the arc length divided by the radius. So if my arc length is 2 meters on a circle that has 1 meter radius, well, the units cancel out. And suddenly you just make up a unit. Oh, there's no unit there, so let's tack in rad. Yeah, you can, but it's not required. So radians, if you're given an angle and you don't put units down, I'm making the assumption you're in radians. Leaving units off, traditionally, on a 10-point problem, -3. Wrong units, -2. And then there's some other things where occasionally kick out -1, it's rare. Like they do an uppercase instead of a lowercase when it's a different type thing. Now, for those of you who are less familiar with whatever calculator you're using or less familiar with trig, please make sure you know how to get this on your calculator. If you don't have your calculator with you, just make a note sometime over the weekend. Make sure you can reproduce this. All right, so I have your calculator, get ready to use it. I'm gonna put up a problem for you to work. And it'd be really nice if I had an example problem right here, just so. Nope, all right. What is theta? I'm grab my calculator so I can figure out what the answer is.
I think that's 4.3,
4.3, 6.2. And that's a right angle between them.
Dr. Fox, assuming we put the degree mark on there, would you rather have it in degrees or radians?
For the most part, we'll deal in degrees until we get to somewhere near the end of the course when we get to the vibrational motion, at which point we'll probably play in radians at that point.
Okay, and we don't need to worry about sig figs with this, do we?
No. Worry about them if you want to.
I do.
Do you have a, did you already calculate the angle?
Did I calculate the angle? Oh, that's right.
Yeah.
That's,
Mathematically, that doesn't follow.
that's true. I skipped a couple steps. Are you okay with us writing out ARC?
Yeah, yeah, I'm fine with that. I just write the A because I don't like writing.
I used to have one of these, and it didn't do it in the factory. So you didn't get this from degrees 4, right? just
What do you
put
think
in
this is for?
Oh,
tan
you're
negative
doing-
one. Don't
You
worry
figure
about
out
the
that one,
section
because it's gonna
function.
do our stuff.
Oh, I see what I did.
Yeah.
Then you can.
Just do the inverse thing, right?
Yeah, you do that, Mark.
And that's 55.26. Solution.
Oh. Yeah, you're doing.
Oh,
We
we
do,
don't,
that's
that's
why
why.
we are,
I don't have a calculator on me, I should.
when you're doing a tan,
On my phone.
tangent has to be up at an angle.
Oh, wait.
Well, that's right.
Yeah, you're right. I'm having trouble
I saw two tangents and I'm
Why
like,
is it doing that?
You can download an app called
All I did was just put the number.
I have to do it like,
Is that right?
circle.
You know? There we go.
I was like,
Yeah, try
I
to
what
get
is
it.
it doing? It's taking this, I don't know why.
Oh, and this is why I don't like this notation right here, because inside you're doing a reciprocal.
Oh, is it not?
It's not reciprocal.
Okay.
Yeah, it's-
You got it.
I,
You got
I
it.
don't, nobody on a
So that's
calculator,
degrees
so I
are
got
right.
it.
really good.
Okay.
Yeah, there's,
It wasn't on that.
but there's some calculator programs on the phone are more sophisticated than others.
So if you get a
Yeah, it doesn't look like it has.
You have to do.
If you go to your calculator and then you side with it,
Oh, really? Just like-
you just did
Yeah, and then.
So you did the paper first, right?
It's
The whole number.
Do,
Okay, that's why.
Okay.
Because if you're putting the whole decimal, it's gonna have something matter.
I took it with.
Whereas if you put it in one or the whole calculation, you won't have to type it.
It was really good, 'cause you like it right out.
So the tangent on like this, it was so nice, but the tangent going on the angle was
And then it gives you all the
that way.
answers.
So.
Oh, I'm sure.
You guys got it?
All you have is a ratio of sides here. So we're trying to find an angle, not the ratio of sides. So the tangent of that angle.
In contrast, I have a health teacher.
So to get the
that
angle,
literally was like
you have
trying
to
to
find-
make me retake the class.
Get the tangent.
She was like, you need a doctor's note. I was like, I don't have health insurance.
Right hand side.
Yeah. That's
I was like, what do you want me to do? I'm not purposely missing the day of the final.
Yeah.
It's just like,
You got with it.
This is from a significant figures point of view.
Yeah.
You would take this out as bar, you only do the rounding off at the very end.
at the very, okay, gotcha.
So you won't have to.
That's all, just make sure you do your work.
Put it in
But
before
that's
the
where,
number.
like, they have decent insurance and.
People are in different spots here, and some people are still working on it. I'm gonna do two approaches here. First approach is just straight up. All I'm gonna do is find this angle here. All I have, I'm given opposite and I'm given the adjacent. I'm not given the hypotenuse, so sine and cosine I can't do without doing something else first. So I'm gonna go straight to tangent. The tangent of the angle is the opposite side over the adjacent, which I believe is 1.4 something. Now, I'm trying to find the angle here, so I need to get rid of tangent, and I do that with the reciprocal function, or the arctangent. So theta is equal to the arctangent of 6.2 over 4.3. And some people did this fraction first, and then did the arctangent, and some people just type this all out at once. And you end up with 55.26 degrees, or 0.9644 radians. We'll look forward to the day when I can pull hair out of my eye without having to cleanse my hands first. But now I've got alcohol on my hands, let me put it near my eye.
You know, I'm not sure if this is true for, the hand sanitizer, but there was like a video that was released as soon as COVID hit. And it was about why you should be washing your hands for 2 minutes. And it's because the soap breaks down like the oils and the fats on your hands. And it just like, it has to take 2 minutes to do it. And I remember my parents saying, watch this. So we sat down for 2 minutes and I watched it. And that's all I remembered.
20 seconds was what I heard was all was needed instead of 2 minutes, but, you know, I'm paranoid enough.
Yeah.
Worth
I'd have to learn a
remembering-
2-minute song, sorry?
Sorry, didn't mean to cut you off. But it's also worth remembering that like COVID does not transmit very easily from surfaces. Initially, they thought that it did, but the researchers are like, wait a second, it's actually primarily just respiratory in the air and breathing,
Yeah.
all of that. But paranoia, I understand and I feel it.
I don't wash my food anymore when I
Right,
come indoors.
that's not
Glad you got past that.
Yeah.
For the historical record.
For the historical.
Alright, so let's use sine and cosine, or arc sine, arc cosine. Obviously, sine and cosine have hypotenuse in it, so we need to figure out the length of the hypotenuse. And how do we find the hypotenuse? What's the magic 2 words? That's the one, or those are the 2.
Remember.
Brings back some good memories. If it is a right triangle, the Pythagorean theorem is true. If the Pythagorean theorem is true, it has to be a right triangle. So given a triangle with lengths A, B, and C, right triangle, A squared plus B squared equals C squared. I was taking general relativity class in graduate school because a friend wanted to take it and he suckered a couple of us into taking this class also. And the teacher had a very thick accent. And he's talking about the theorem of Pythagoras. And I'm going, Pythagoras, I have no idea who that is. And he looks out at us and we all have these blank looks on our faces. And he goes, you know, the theorem, Pythagoras. A squared plus B squared equals C squared. And then there's that wave of, oh, Pythagoras. My goal in the first test for that class was to understand the questions. I did not succeed. But Bill prepared, it shows me. Alright. So, Pythagorean theorem. 4.3 squared plus 6.2 squared is equal to, well, let's be clever and just use h, equals h squared. The biggest mistake I see students make at this point is the math is no problem up to this point, but then they'll forget to do the square root at the end. So first h squared is equal to something and then h is equal to.
H squared is equal to the square root of 56.93. Or yes, no, it's, yeah, and then the answer is 7.545.
Now this is an intermediate calculation. If we cared about significant figures, which we really don't, but if we cared, we would write out, we would use the full whatever we come out with. Don't round off at this point because again, it's intermediate. We're not presenting our answer. And so now the cosine, or we can just skip a step, theta would be the arc cosine of 4.3 over 7.545, whatever it happens to be. I assume it was not exact. Or theta is equal to the arc sine of 6.2 over 7.545. And I'm thinking it's somewhere around 55.26 degrees, but I just did that in my head, so Oh, Brooke.
Why would we not round if we cared about sig figs?
The rounding would happen in the final answer. It's, again, significant figures is about presentation in the end.
Okay,
So you keep all the intermediate ones as you go full length.
okay.
Related to that, if we're writing out all of our work, at this point, we would write out all of the digits that we came up with to demonstrate like the number we got at that intermediate stage, right?
Yeah,
And just put a dot, dot, dot at the end.
yes,
Okay.
that's fine.
Yeah.
On test or quizzes, on labs, I'm checking you out to however, you take it 10 decimal places, I'm checking you out to 10 decimal places. After the first lab. On tests and quizzes, it's, okay, close. At some point, I stopped looking at decimal places. Maybe, is that a question or just, okay.
Well, I guess, okay, can I rephrase just one more time?
Okay.
So at this point, would it be just as accurate if we were to write 7.545 dot, 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 and then do our calculation with the full number?
Yes.
But not necessarily write out the digits for each?
Yeah, I am perfectly fine with that.
Okay, thank you. Got it.
And let me talk about on the lab, oftentimes, on a lot of the labs, you can do your work right there on the piece of paper, that's fine. Sometimes people will do reams and reams of their work. If you have a whole lot of extra work or you're using a spreadsheet that's separate from the lab papers themselves, if you were sending me something in through email, as it should be for supplementary information, if I can follow all your work and I match your numbers, I don't have to look at what you send me in the email. So, but some people do a lot of extra work and they wanna make sure they show it to me. I will look at it if I need to, but I should be able to look at just the paper and go, okay, yeah, I'm matching everything this person has. I don't need to see the work. Or I don't see how they get this. Okay, now I can look over here. And I don't know why this means I'm looking at a spreadsheet on a computer, but that's what that was. All right, let's go the other way, which we will do probably more often than this way. A right triangle, surprise. (35°). Now let's give it context. I want to know what the length of the other two sides is. So this is going to be closer to straight up trig functions, no arc functions. I'm going to call that A and B. Pick the letters of your choice. I know that the cosine of 35° is the adjacent divided by the hypotenuse, so that is equal to A divided by 10. Now, I did not write down meters. Technically, it is 10 meters, but I don't need to show my units as my work progresses because I know what the answer is going to be. A is going to be in meters. B is going to be in meters. I don't have to write meters in the intermediate work. Doing the fancy cross multiplication, A is equal to 10 cosine 35°. Now, in a lot of problems here, this is for the people who have their calculators in radians. For a lot of the problems here, you will be given in degrees, at least for the first 2 months. So just please make sure that you account for that. I know that this answer has to be a positive number, so especially if you're in radians and suddenly you get a negative number, that should be a warning sign that something's off. So somewhere around 8.2.
Yeah. How'd you do that?
37 degrees or 36.8 degrees is a 3, 4, 5 triangle. I'm slightly off of that. So I knew it was something a little bit bigger than 8. The 0.2 was sort of a stat. B, I now have 2 choices here. I have A, which has 8.2 here, presumably 8.2 and a whole bunch of other numbers. I could find B using Pythagorean theorem. Or I could use trig functions. Why was it better to use a trig function here?
Cause you already have the angle.
Okay,
No.
what,
Using your given information as opposed to something you already calculated.
what's wrong with using a number you calculated?
Might be wrong.
That's wrong.
Okay, make sure you show your work. I've heard that somewhere before. The other thing is that some people, now the calculators, if you still have it stored there, that's fine, but some people will write it down and then they'll type in whatever they wrote down, as opposed to just using the number that's right there in the calculator. This 8.2 is rounded, so we've introduced a little bit of inaccuracy there. If you got the full 10 digits or whatever your calculator can hold, then it's less of an issue. But if we're using trig, then I know b over 10 is equal to sine of 35 degrees. 5.8.
5.74, excuse me.
All right, so we have our two answers right there. The math part, we're feeling good with. I'm taking points off.
There's,
Yeah, so for A, for some reason I had like 8.191, like.
Oh,
I
that's
know
correct.
you said that it was somewhere around 8.2, but I mean, like, when you count that off?
I was just figuring ballpark at this point.
Okay.
So why, Anna,
sorry, Jeff, go ahead. Say what you're gonna say.
why would I take off points?
Units.
Yeah, meters, meters.
My question
Yeah.
was related to that. So when we're showing our work, in this context, we don't have to put meters or whatever the unit is for the intermediate steps.
Right.
And that's specifically for the trig functions. Because in general, I feel like for physics calculations, you want us to include meters as we go, right?
No, that's gonna be true throughout the course.
Okay, just the final answer, you want meters, but the
Yeah.